All right, so on my screen, I have three different equations, and I want to talk about how you can solve equations, systems of equations. If you don't know how to solve equations, you can still solve a system of equations, especially if you are test taking. So I pulled these three because they represent the three different types of solutions that you can have for a system of equations. On this first problem, we have an infinite solution. Then we have no solution, and we have a solution that has an order pair. When you graph a system of equations, in order for a system to have infinitely many solutions, they have to be the same line. And these two equations represent the same line. Look over here at this equation. We will see that the x-intercept is 10 because we want to find out what happens when y is 0. Well, when y is 0, get x equal to 10. So it's going to cross the x-axis at 10. When x is 0, y is going to be 2. So it's going to cross the y-axis at 2. So this is the first line represented by that first equation. The second equation is not in slope-intercept form. And if we were to write it in slope-intercept form, or better yet, let's substitute 0 in for x. When we substitute 0 in for x, we get that 5y is equal to 10 and y is equal to 2. So again, it's going to cross the y-axis at 2. If y is 0, then x is going to be 10. So it crosses the x-axis at 10. This is the same line, so it's infinitely many solutions. Notice when you solve by substituting, you'll get 20 equals 20. The same. Same numbers on both sides, same line that is graphed infinitely many solutions. On the second equation, it is no solution. So what that means is these two lines must be parallel. Notice that this one has a positive slope of 3 and a y-intercept of 4. So it's going to intersect the y-axis at 4. And it has a slope of 3. So you rise 3, run 1, put a point. There's your graph for the second equation. Now, notice I'm not using substitution. And I'm not solving equations. On the first equation, it's not solved for y. But if x is 0, then the opposite of y is 6. So y is negative 6 when x is 0. So x is 0, y is negative 6. And when y is 0, we have 3x equals 6, y is 2. So when x is 0, y is 2. You put a 0 here for y, and you're left with 3x equals 6, and you solve it. So 0, 6. I substituted 0 in for this value. So when y was 0, x was 2 for this equation. So this order pair is 2, 0. And when we plot these two lines, they are parallel. Parallel lines never intersect, and therefore they have no solution. They have no solution because they never intersect. Notice that when it was solved, we have a negative 4 equals 6, and that's not true. So I solved and worked on systems of equations without ever really solving a system. Now let's look at problem number 3. On problem number 3, this one is what we worked on yesterday, but it has y equal to an expression, and that expression is in slope-intercept form. If you are taking a test and it is substitution, and it's a multiple choice, you don't have to know how to solve a system of equations. You have to know how to take a test. So they are telling you that this is X and this is Y. Plug it in, plug it in. If you substitute 2 for X right here, and you substitute 5 for Y, will you get 19? The answer is 4 plus 15 is 19. Yes, it works for one, it's got to work for both. So we look at the second equation. 2 times 2 is 4, plus 1 is 5. Is Y 5? Yes, Y is 5. So if it works for both equations, it's the solution. And that is how you can approach systems of equations without really knowing how to solve a system. Should you learn how to use substitution? Absolutely. I'm not saying don't learn substitution. I'm saying that if you even if you don't have the process of solving systems using substitution down pat, you can still have enough in your arsenal, in your backpack to survive a systems of equations unit test. That's my point. All right. So now I am going to stop sharing.